Hello there everyone, welcome back to Ants Authority. Today we will discuss about the topic, do ants need oxygen to survive? In this video we will discuss about this topic in detail, so let's start the video. Ants need oxygen to live as their cells metabolize food and produce energy. They can live for almost 20 to 24 hours without oxygen due to their smaller bodies. They can survive underwater for some time without getting short of breath. Ants have different breathing mechanisms due to their smaller bodies, as they cannot hold the complex and larger organs in their tiny bodies, as it can increase their overall body weight. They have to be lighter as they have to walk long distances, locate the food sources in their surroundings, and have a high metabolic rate compared to resting mammals. Oxygen is essential for living organisms as their cells need it for proper functioning or metabolism. In addition, it acts as a fuel for tissues and muscles and keeps their internal systems running. They do not consume molecules from the air due to the absence of lungs, but they take in the molecules from the spiracles or breathing holes in their body. Moreover, the diameter of tracheal tubes and the concentration of atmospheric oxygen determine the number of molecules that can diffuse into the tubes and enter the body fluids. It becomes difficult for cells to metabolize the food particles and get energy in their absence. When they begin to suffocate, the spiracles open to allow air exchange within tracheal tubes. In addition, they have to allow air intake by opening the spiracles and providing a passage to reach the tracheal openings and get mixed with hemolymph. The opening of spiracles is under their control as they can close them when they have captured a sufficient amount of air molecules. So they need it to sustain life like every living organism on the planet, but their requirements could vary from others due to differences in body size. Ants do not need a large amount of oxygen to live as their smaller bodies have fewer cells compared to larger animals. Moreover, their metabolic processes are not fast enough to increase the intake of molecules into their body fluids. Their smaller bodies can easily manage blood flow through the larger duct. They ingest simpler food molecules that can be easily digested without posing a burden on their cells to produce a large amount of energy by metabolizing the complex particles. The amount of molecules these insects require depend on their lifestyle, as a few ants are active, perform multiple daily tasks, and walk long distances. However, some have a sedentary lifestyle and remain inside the nest in a resting position. As a result, they do not participate in tough tasks and their cells need lesser energy to survive. The metabolic rate of ants living a sedentary lifestyle like a queen is almost 0.326 at 77 degrees Fahrenheit, while that of workers is around 0.410 because they remain more active than a queen. Continuous movement allows more molecules into the tracheal tubes as the mass of airflow increases. In addition, the abdominal muscles can contract and relax to create a better airflow. They can provide a pumping movement and improve its intake into tracheal tubes. Moreover, they can maintain almost 5 times lesser concentration than atmospheric concentration. These tubes or the overall respiratory system can keep almost 4.5 to 5.2 kilopascals of oxygen, while the standard atmospheric oxygen pressure is around 19.7 kilopascal. Ants need a small amount of oxygen to survive and store the molecules in their respiratory tract, which makes them able to remain unaffected if they do not get exposed to air for some time. They can survive without it and do not die of suffocation if their bodies do not get exposed to atmospheric oxygen for almost a day. Moreover, the stored molecules are enough to be used for at least 20 to 24 hours without making them die of suffocation because their metabolism is slower than ours. They open spiracles to breathe in more molecules when the stock of oxygen reaches an end, as these molecules have to pass through these holes to get inside the tracheal tubes. In addition, these insects take a long time to consume its small amount, which humans or other animals use in a few minutes. That's why you can keep them in closed jars. However, there is a risk of death when the stored stock of oxygen reaches an end, and there is no option to breathe in more air to fill up the tracheal tubes. Accordingly, you have to keep them inside closed containers for more than a day because they can remain alive for almost 24 hours. Thanks for watching the video.